Welcome to Ask and Learn.
This problem just requires a systematic application of Newton's laws to our bodies in the problem. And so we have two bodies, the bar that's hanging, and again, it looks like, I assume it's hanging vertically. They didn't say that, but I'm going to assume that this is true. If it wasn't, then we could set g equal to 0 and then get the answer for when it's rotating when in a plane perpendicular to gravity. So, free body diagram for this, we have reaction forces at the pin here, the weight, and then the force from the spring. And now we're going to make a lot of small angle assumptions here, and I'm going to kind of I'm not going to write them out explicitly, but I'll talk about them. So here we have a moment from the weight, and the moment arm is that length there. We know this is L over 2, and we know this angle here is theta. So this would be this length here would be L over 2 sine of theta. Well, sine of theta for small theta is roughly theta. So that's where we get minus mgl over 2 theta, since I replace sine of theta with theta for small angles. Then we have the moment from the spring here, and again, the moment arm here is not quite L actually, right? It is, since this is L, the perpendicular, the moment arm is actually L cosine theta, but theta, to a linear approximation, theta is roughly 1 minus 1/2 theta. Cosine of theta is roughly 1 minus 1/2 theta squared. So the linear approximation is simply 1. So that's where we just get the approximately the moment arm here is 1, or is L if theta is small. And then we have the mass moment of inertia about the pivot point here for a uniform bar, and then the angular acceleration. And then for the spring, we have to look at a free body diagram of the spring, and so we have equal and opposite forces here, and then an equal force on the opposite side of the spring since it has no mass, or we're assuming it doesn't have any mass. And then the displacement here, again, this really is L sine of theta, but I replace sine of theta with the approximation of theta. So that's the displacement there. And we can see here that a positive displacement here is going to give a negative force. So we need a negative sign in here. So again, if we put a positive force on it, we should get a negative value for this. So we need this minus sign here. So Fs equals minus KL theta, since this is the change in length of the spring. Plugging this into here, rearranging some, and canceling out an L everywhere, we get that what I'll call the equivalent stiffness. So all the thing is the coefficient of our coordinate, which in this case is theta, is KL plus mg over 2. The equivalent mass, which is all the things in front of the acceleration term, is 1/3 ml. And so the natural frequency is the square root of the equivalent stiffness, all of these terms, divided by the equivalent mass, all of these terms. And we can substitute in, do some rearranging, and we get 6KL plus 3mg all over 2ml is the natural frequency. And the natural period is just 2 pi over this, so that is given by this expression here. So we can see a couple things, I suppose. So we can check this a little bit. So as L gets really small, we can see that the natural frequency is going to get very large, because again the mass is we're going to have no inertia as we get L very small. So L very small, this goes away compared to this, and this goes, gets very small, so this is going to blow up to infinity. So that makes sense. Now, if M gets very small, same thing. Or just, well, this is going to go away compared to this, and then this is going to get very small, and we're going to go blow up to infinity. Now, if, let's see here. If K goes to 0, then we just get that drops out, and we get our kind of a pendulum equation. And we notice that if K goes to 0, then M's will cancel out. And so again, for like a pendulum, we know that the mass should matter. And so that's the case if K is 0. So again, you can do a little checks. If G is 0, then this goes away. So if it were in the horizontal plane, then that would go away, and then we just get 3K over L, or 3K, square root of 3K over M, sorry.